Hi everyone, welcome to the Introduction to Electrodynamics by Griffiths, problem 4.37. So this is actually a very interesting problem because it tells us how to derive the Snell's law in the optics. So the key to this problem is the boundary conditions. And so we can see that for electric field, there are two boundary conditions. The first one is here and the second one is here. So in the question, it says there is no free charge. So we know that, well, there is no free charge, but we don't know the total charge. So because we don't know the things here, so we can't use this relationship at all. So what can we use? Well, because we know this is 0, so we can use this. This is just 0. So perpendicular minus perpendicular below is equal to 0. So they're equal. Now we know they're equal. And also, what do we know? We know that the parallel, they are equal. So the parallel electric field is equal. Okay, so this part is a parallel part. So they are equal. And this is the perpendicular part, and they're not equal. Let me label them. This is E1 perpendicular, E1 parallel. 2 perpendicular, E2 parallel. Okay. So now let's represent tangent theta. So tangent theta 2 is equal to E2 parallel divided by E2 perpendicular. Okay. And then what is tangent theta 1? It is equal to E1 parallel divided by E1 perpendicular. Okay. So now we know that E1 parallel is equal to E2 parallel. So this is just a rewrite of this equation. But now we don't know what is E1 perpendicular and E2 perpendicular. But luckily, we know them. So we know the relationship D is equal to epsilon E. So we know D1 equals to epsilon 1 E1. So E1 is equal to D1 divided by epsilon 1. So as the same idea, E2 is equal to D2 divided by epsilon 2. Okay, now we know them. Of course, everything is perpendicular. So don't confused by my writing. Everything here is perpendicular. Okay. So now we plug in everything we have. So let's write in the form that the question wants us to do. So tangent theta 2 divided by tangent theta 1 is equal to, so I'm just copying things and I changed the sequence because we're dividing. Okay, so now plug in everything. So because they're just equal, so I can choose either one of them because they will cancel at the end. So let me choose to keep this one. So E2 parallel is equal to E1 parallel, and E2 perpendicular is equal to D2 epsilon 2. So E1 perpendicular is equal to this. and E1. Okay, they will cancel. And because we know that D1 perpendicular is equal to D2 perpendicular because I write it here, so it's just a rewrite. So they can actually cancel too. So now what do we have? We have epsilon naught 2 divided by epsilon naught 1, which is exactly this form. So now we have our answer.